Alrighty, so what I want to do now is give you some more examples of doing the conversion problems and the metric problems. I know some of you finished it and turned it in, but I also know that some people, this can be a little bit confusing. And so I have created another set of problems that are very similar to the ones you had for your homework. Um, and there's no problem of you going back and fixing things that might have been a problem. So, in this first one, Mikolas Alekna broke the Olympic record in the men's discus his father had set 20 years ago with a throw of 69.97 meters, only to have his record broken a few minutes later when Rajay Stona of Jamaica threw 3 centimeters further at 70 meters for the winning throw. How far is 69.97 meters in feet and inches? I have given you one way of doing it. 1 meter is 3.28 feet. So, first off, I can write 69.97 meters times 3.28 feet per 1 meter. Then use my calculator. And this gives me 229.50 feet. Now, I want feet in inches, so I'm going to take the partial foot part, in this case just the 0.50, times 12 inches per foot. That part equals, of course, 6 inches. So basically, he threw 229 feet, 6 inches. That's what 69.97 is, 229.6 inches. 3 centimeters further, roughly an inch and a half. So the guy lost after setting an Olympic record. He then lost and got second by an inch and a half. All right. There was a race in the Olympics, or a bicycle race. This was the longest race in the Olympics. It was 273 kilometers long. Again, we don't really have a good feel for kilometers. What would this be in miles? So I have 1 kilometer is 1,000 meters. So I'm going to take my 273 kilometers times, and now 1,000 meters over 1 kilometer. That will get me into meters, and then I'm going to use my second. 1 mile is 1,609 meters. So it's 273 times the 1,000 times 1, divide by 1, divide by 1,609. And basically it comes out 169.67 miles, which, since I only had 3 digits, I would have rounded this to 170 miles. With 1 decimal point, that 1 decimal point will mean that the 0 counts as a significant digit, but I didn't put another 0 because then that would have meant 4 of them. And I started with 3, and so I have 3 here. But if I hadn't put the decimal, then that 0 wouldn't have counted, only the 1 and 7 would have counted. In other words, I would be saying accurate to the nearest 10 miles, when actually I can go to the nearest 1 mile. I'm sure most people have heard of Simone Biles. You might not realize she's only 4 feet 8, even though she looks huge on the screen, but only 4 feet 8. The question is, how many centimeters this is. So first off, we have to recognize that 4 feet 8 inches. Okay, well, I need to get all of that into inches. So first of all, 4 feet times 12 inches per foot gives me 48 inches, which means when I add them together, 4 foot 8 is 56 inches. Now that I have that, I can go ahead and go into centimeters. 56 inches times 2.54 centimeters per inch. And we're going to end up with 142.24 centimeters, which I'm just going to say is about 140 centimeters. I'm not going to put the decimal that time to say, really, I don't want it to the 1 centimeter mark, but so approximately that. Any questions so far? Make sense? This is what homework problems should look like in terms of showing your work. All right, how many seconds are in one day? And I put a couple of zeros there to give us 3 significant digits, not just one day, but 1.00 days. So a little bit more accuracy there. And of course, this one, not too bad since I know that there are 24 hours in a day. So 1.00 days, 24 hours per one day. And then I know that, hey, there's 60 minutes per hour and 60 seconds per minute. Multiply all those things together, and I'm going to end up with 86,400 seconds in a day. And for those of you who are of the performing arts, there was a musical called Rent, in which that is one of the key features, one of the songs in the musical, the fact that there are 86,400 seconds in each day. Sounds a little bit more intimidating when you say 86,400 than just one day. But that is part of the idea behind conversions is, taking numbers that might be a little bit more difficult to put your mind around and turning them into something else that's much easier to think about. All right, also in the Olympics, Noah Lyles won the 100 meters. He ran 100 meters in 9.79 seconds. So the question is, how fast is this in miles per hour? Interestingly, if you actually watch the race, they not only showed how fast it was in miles per hour, but they showed how fast the different runners were running at various stages of the 100 meters. In other words, he didn't actually run the same speed the entire time. Most of them had a slightly slower speed for, say, like the first 40 meters, and then they had one speed that was kind of in the middle, and then some of them, even though it's only 100 meters, tended to get a little tired by the end and maybe slowed down. So this one has 2 units. We got meters and seconds. So I'm going to start off with 100 meters. In 9.79 seconds. And then right here I've got, well, in miles, 1,609 meters approximately is 1 mile. So I'm going to do 1 mile and do that one over the 1609. This will, of course, get rid of the meter part, but I still need to change the seconds. And you might remember from before, how many seconds are in 1 hour? There are 3,600. 60 times 60 gives me the 3,600. And then that's in 1 hour. And it turns out that ends up being 22.854 miles per hour. Since basically these are like 3 digits each, I would say, approximately 22.9 miles per hour is how fast he was running for that 100 meters. And then in the last one, I think on the homework you had green light. This is red light. So similar starting point, just a different color. Basically every color in the rainbow, if you will, has a different distance from one wave to the next. That's what we call the wavelength. So imagine, one ocean wave and the next. Well, that's pretty far apart. But for light, that's pretty small. In fact, if we wanted to say, what is that as a regular number? The 6.65 times 10 to the minus 7. Okay, that's in what's called scientific notation. As a regular number, it would look like this. Very tiny. Okay, that's 6 zeros before I got to the 665. I can write this, I can do this number with my calculator, because most of the calculators today have 10 digits, or at least 9 digits on the screen. But if I go past that, I can still write it this way in what's called scientific notation, whereas I cannot put that many zeros on my calculator. By the way, on a calculator, let me turn it on. If I want to do that scientific notation, let's see. There is a button on this particular one. It's the EE that allows me to do that. And so if I want to go 6.65, and then I hit second and the EE button right there, that means on this particular kind of calculator, that's doing this part, the times 10 part. And then I need the -7. So I have to use this key, which means do the negative part. I don't use the subtract key because I don't want to subtract. I just want the sign to be negative. So I hit negative and then the 7. And so that's the way that it appears on the calculator, 6.65 e to the -7. There are other calculators, and I really advise you to get your own calculator. There are other calculators in which instead of that e, it'll actually do a little times 10. And then it'll take the -7 and actually put it up a little bit so that it looks a little bit like this does here. So that's doing scientific notation on your calculator. I want to change this into nanometers. And if we go back to the metric page, the metric worksheet, again, you're never going to have these things memorized. I gave it to you here in the problem, but it's also here. The nanometers, NM, let's see, There it is, nano, 10 to the minus 9, or basically there are 1 billion nanometers in 1 meter. Again, imagine a meter stick divided into centimeters, so that's divided by 100. For a nanometer, that's taking the meter stick and dividing it 1 billion times. So we're going to take our 6.65 times 10 to the minus 7 meters, and then times 1 nanometer, nm, over 10 to the minus 9 meters. Now, I do that on my calculator. So basically, I'm going to go times 1 divided by, now since I want that 10 to the minus 9, I'm going to do 1 and then second e to get that scientific notation part, negative 9. So that 1e negative 9, that's the same way as doing this. Go ahead and equals, and it turns out that's what it is in nanometers. In other words, not too bad a number to look at versus what looked at. And really a lot of the metric conversions are about, hey, let's just call it this number instead of calling it that number, so that we don't really have to deal with the scientific notation at all. The same thing happens, for instance, with things like pH. You know, they'll tell you something is pH balanced, and it'll be around 7 or maybe 6.9 or something. What they don't tell you is that's actually doing this kind of thing. It converted it from what it was, which was something like 5.2 times 10 to the minus 7 kind of thing, because of what pH really is. And we'll find out more about pH in the spring. All right. Now, red light, we have a second part. Red light has a period. The period is the time for one wave to go by. So the wavelength is how far apart the waves are, and then the period is how long it takes one wave to go by. And that's done in seconds. And in this case, as you can see, it doesn't take very long for one wave of light to go by. That's 10 to the minus 15. And so I'm going to go 1.73 times 10 to the minus 15 seconds times 1 femtosecond. And again, don't have to know this. It's here in the problem, but here is femto. Okay, this is 10 to the minus 15. That's the quadrillionth of a meter. And what's kind of nice about this one is that's 10 to the minus 15. That's 10 to the minus 15. They just cancel. And I'm left with 1.73 femtoseconds. Now, your numbers on the homework were a little bit different because you were looking at green light instead of red light. Blue light would have been a different set of numbers as well. But that's the idea behind doing either the metric conversions or the conversion problems themselves. Honestly, the big difference between the two is notice that when I'm doing metric type conversions like these guys here, the numbers don't change. 665, 665, 1.73, 1.73. It's just the unit changed. That's all that's happening when I'm going from one metric number to another metric number. On the other hand, if I'm doing something that converts between, feet and miles and stuff, then I end up actually in a different set of digits. So here, 6.697 meters, 229 feet, 6 inches kind of thing. Any questions on doing those kind of problems? Our next quiz probably have one or two of these to do. Okay, it won't be the only thing on it, but problems like that. Okay, any questions?